Hello! Let's talk about injective functions today. Very important thing in mathematics. Take a function from a set A to a set B. As you know, f is the name of my function, A is my domain, B is my codomain. Okay? I'm going to say that a function from a set A to a set B is injective whenever I take two different points of my domain, x1 and x2 belong to set A, my domain. If they are different, then when you apply the function, they are going to be mapped to different points of my codomain. So f of x1 will have to be different than f of x2. Okay? So that's the definition. Whenever I take different points of my domain, they go to different points of my codomain. Now this, in logical terms, it's equivalent to this next line here. It's called the contrapositive. Something implies something else. So P implies Q, a condition P, a statement, a logical statement P implies a logical statement Q. It's the same thing as not Q implies not P. So not this, what is the negative of saying that two numbers are different? Negative is they are the same. Okay? So the negative of this is this, and the negative of this condition is that. Okay? So this is saying that whenever x1 and x2, 2 points of my domain, go to the same point of the codomain, is because they were already the same point to start with. Okay? So that's, you can use that or that in exercises, whatever you feel better. Let me show you some examples. I want to show first that I have a function from real numbers to real numbers, like f of x, 2x plus 3, so the graph is a straight line. Choose the slope, 3 is the y-intercept. This formula gives me this function from real numbers to real numbers, and it's going to be a straight line, something like this. Okay? If I plot here, the graph of the function is this straight line. 3 is my intercept here, the slope is 2. So suppose then I have 2 points on my x-axis, x1 and x2, and the function is the same. Well, if the function is the same at x1 and x2, I can apply the formula, and f of x1 is going to be 2x1 plus 3, and that's going to be equal to function of x2. I plug x2 here, 2x2 plus 3. I cancel the 3 here. I divide both sides by 2. And what do I find? I find that x1 has to be equal to x2. Okay? Subtracting 3 from both sides is a valid operation. Dividing by 2 in both sides is a valid operation. So, yeah, I use this and I conclude that this function here is injective. Okay? So basically, if you pick any 2 points here, the heights will be different. If x1 and x2 are different points, the heights will be different. Okay? Another example, a more complicated one. So now I have a function. My domain is not the real numbers, but the real numbers except for the number 7. I do not define the function at 7 because I would have a 0 in the denominator. So to escape that, my domain does not contain the number 7. But other than that, here's the formula for the function. And I will do the same trick. I will suppose f of x1 equals f of x2. And I have to show if this function is to be injective, and I suppose it is, otherwise I wouldn't pick this example, that I will have to show that x1 is equal to x2. How do I do that? So if we start with this assumption, we start with this part here, we have to show that x1 is equal to x2. F of x1, I substitute x1 here, and I have that. 2 times x1 plus 3, x1 minus 7 in the denominator. And it's equal to the function calculated at x2. So I plug x2 here instead of x. So it's going to be 2x2 plus 3, 2x2 plus 3, divided by x2 minus 7, x2 minus 7. Okay? Now I cross multiply, so I have this numerator times this denominator here equals to this numerator times this denominator. And for this equation, I have to show you that x1 equals x2. Let's do that. 2, so I will multiply this by that, then this by this by that. 2x1 times x2, 2x1 x2, then 2x1 times minus 7, it's going to be minus 14x1, okay? Then 3 times x2, and then 3 times minus 7, and this is going to be equal to this. I will do the same thing here. This times this times that, this times this times that. I'm going to write here. 2x2 times x1, it's going to be 2x2 times x1. Then 2x2 times minus 7, minus 14x2. 3 times x1, 3 times minus 7. So I have this equation here. This bit equals to that. In both sides of the equation, I have this term here. I can subtract. In both sides, I have the negative 21. I can cancel out. And then I can push these two terms to the other side. This goes to the other side, becomes 14x2 minus 14x1. Okay, this term is this is that. Then I'm going to write this one here. And this 3x1 goes to the other side, becomes minus 3x1. And everything on the right went to the left, so I'm left with 0. So what do I have here? How many x2s? 14x2s plus 3x2. I have 17x2. And I have minus 17x1. Minus 14x1 minus 3x1. And that's 0. So I'm going to have 17 multiplying x2 minus x1 equals 0. And if the product of two numbers is 0, it's because at least one of the two numbers is 0. 17 is not 0, so the number that must be 0 to make the product equal to 0 is this. So from here, I discover that x2 minus x1 is 0, which means that x2 equals x1. Okay? So if the difference of the two numbers is 0, it's because the numbers are equal. So I'm done. I started assuming that the function takes x1 and x2 to the same number, and I prove after a long calculation that I started with x1 and x2 have to be the same. Okay? Therefore, this function here, it's going to be injective as well. Now for a final example, consider functions fk from this domain, the set with numbers 1, 2, to this codomain, the set with numbers 4 and 5. What are all possible functions? So to define a function, I have to tell you where one is going to be going to. One can go to 4 or one can go to 5. And I also have to tell you where 2 is going to go. 2 might go to 4 or 2 might go to 5. Overall, I have 4 different functions. Okay? In this first function here, I'm calling f1. 1 goes to 4 and 2 goes to 4. It's the constant function. Both points go to 4. Here, f1. f2, the 1 goes to 4, but the 2 goes to 5. In the function f3, the 1 goes to 5 and 2 goes to 4. And the function f4, 1 goes to 5 and 2 goes to 5. What are injective functions? If I have 2 different points, I have to map to 2 different points. Is this injective? No, f1 is not injective. Because both 1 and 2 are different points of my domain, they go to the same point of the codomain. So this function f1 is not injective. How about this f2? 1 goes to 4 and 2 goes to 5. They go different points, go to different points. So this is injective. How about f3? 1 goes to 5 and 2 goes to 4. Yes, this is injective. Right? Different points go to different points. And f4, the 2 points go to 5, so this is not injective. Okay? Because 2 different points of my domain are mapped to the same point of the codomain, so this f4 function is not injective. Okay? So some examples of injective functions as examples of functions which are not injective. Very important, we need this concept to define the inverse function, which is extremely important in all sorts of ways in mathematics. We need to talk about inverse functions. That's why we need to know really well this idea of injectiveness. Okay? One more observation, if you have the graph of a function, a real valued function, this function here, for instance, is not injective because we have a horizontal line and 2 different points. This x1 and this x2, they have the same height. So this function is not injective. So that's how you know the function is injective, by looking at the graph. You have to pass horizontal lines and search for situations like that, where 2 points of the graph of the function intercept the same horizontal line. If this ever happens, the function is not injective. Okay? Otherwise, if you can never find a counterexample, then the function is injective. Like an increasing straight line, like you draw here, this is injective. Okay? Hope you enjoy. See you next time. Bye-bye.